Okay, Bismillahirrahmanirrahim. Assalamualaikum, Dr. Sila Hayati bin Kamsani, and welcome guys to our short video regarding the subject Industrial Automation. In this course, we have been given an assignment to design an application of an automated system in a manufacturing industry. We have chosen to design a bottle capper in manufacturing industry.
Okay, the pneumatic bottle capper is used in the food industry. So the pneumatics ensures food processing reliability. So what does this mean is that the pneumatic is much more convenient than the hydraulic. This is because the pneumatic uses the air, while the hydraulic uses the oil. So the oil in the hydraulic can leak and contaminate the food. So it does not recommend for the food industry to use hydraulic as compared to pneumatics. So the pneumatic is much more safe than hydraulic. So next we will be using the PLC, the programmable logic controller. The PLC is widely used in the industry. The task of the PLC is to control and monitor a very large number of sensors.
So there are four types of the components. So the first one is the proximity sensor. The proximity sensor is used in the system to sense or track position of the bottle on the conveyor to the capping machine. The second one is the limit switch. The limit switch are used to optimize capping process of the bottles. Okay, the third one is the PLC. So the PLC system are utilized to optimize the capping process. So and the last one is the actuator with high precision double acting cylinder. So the double acting cylinder is to act as the actuator of the machine for its high precision and accuracy.
The PLC program for bottle capping are as follows. The PLC program, based on the PLC ladder diagram, rung 001 and rung 002 are used to operate the conveyor motor. Assuming it takes 0.5 seconds to cap a bottle, so capping is performed when the conveyor is stopped for a second. When push button input 1/0 is open or connected, it will energize the internal relay. Then conveyor motor output 2/1 runs for a moment and stops for a second. Then timer is in auto reset mode by T4 0/DN in series to it. Rung 003 and rung 004 are used to operate bit shift register and capping machine output 2/2. Whenever conveyor motor is in run mode and the bottles are detected by the proximity sensor input 1/2, it sets B3 0/0 bit and is shifted left when conveyor motor runs for a moment. The proximity sensor is placed 8 steps from the capping machine to set bit position to operate the capping machine accordingly. Bit register B:0 is used. Thus, capping machine should operate when B3 0/0 is shifted to B3 0/7. So, when the bottles detected by the proximity sensor is more than 7 steps to the capping machine will operate based on the bit shift register. When accumulated value is between 1 to 5, that is when conveyor is stopped for a second and timer is between 0.5 to 0.5 seconds, which is the time required for capping a bottle. So next, we'll go to the capping machine. The PLC program for bottle capping are as follows. The PLC program, based on the PLC ladder diagram, rung 001 and rung 002 are used to operate the conveyor motor. Assuming it takes 0.5 seconds to cap a bottle, so capping is performed when the conveyor is stopped for a second. When push button input 1/0 is open or connected, it will energize the internal relay. Then conveyor motor output 2/1 runs for a moment and stops for a second. Then timer is in auto reset mode by T4 0/DN in series to it. Rung 003 and rung 004 are used to operate bit shift register and capping machine output 2/2. Whenever conveyor motor is in run mode and the bottles are detected by the proximity sensor input 1/2, it sets B3 0/0 bit and is shifted left when conveyor motor runs for a moment. The proximity sensor is placed 8 steps from the capping machine to set bit position to operate the capping machine accordingly. Bit register B:0 is used. Thus, capping machine should operate when B3 0/0 is shifted to B3 0/7. So, when the bottles detected by the proximity sensor is more than 7 steps to the capping machine will operate based on the bit shift register. When accumulated value is between 1 to 5, that is when conveyor is stopped for a second, and timer is between 0.5 to 0.5 seconds, which is the time required for capping a bottle. So next, we go to the capping machine. The PLC program for bottle capping as follow. The PLC program, based on the PLC ladder diagram, rung 001 and rung 002 are used to operate the conveyor motor. Assuming it takes 0.5 seconds to cap a bottle, so capping is performed when the conveyor is stopped for a second. When push button input 1/0 is open or connected, it will energize the internal relay. Then conveyor motor output 2/1 runs for a moment and stops for a second. Then timer is in auto reset mode by T4 0/DN in series to it. Rung 003 and rung 004 are used to operate bit shift register and capping machine output 2/2. Whenever conveyor motor is in run mode and the bottles are detected by the proximity sensor input 1/2, it sets B3 0/0 bit and is shifted left when conveyor motor runs for a moment. The proximity sensor is placed 8 steps from the capping machine to set bit position to operate the capping machine accordingly. Bit register B:0 is used. Thus, capping machine should operate when B3 0/0 is shifted to B3 0/7. So, when the bottles detected by the proximity sensor is more than 7 or 7 steps to the capping machine will operate based on the bit shift register. When accumulated value is between 1 to 5, that is when conveyor is stopped for a second, and timer is between 0.5 to 0.5 seconds, which is the time required for capping a bottle. So next, we go to the capping machine.
There are several advantages of the pneumatic system compared to the hydraulic, and why we choose pneumatic system in the food industries compared to the hydraulic system. First advantage of the pneumatic system is a hygienic design. The pneumatic conveying system we install are designed and manufactured with high-grade materials for the food processing sector. The type of material need to convey and the size of the workplace to ensure that it will be easy to clean, repair and maintain. For the second advantage of the pneumatic system is safety environment. Pneumatic system is that if it leaks, it does not contaminate or affect the environment or atmosphere by reducing the safety hazard of using such as a system compare use the hydraulic system. Third is easy clean components. Hygienic materials and processes which are appropriate and which adhere to the strict hygiene processes associated with the food industry. We are even using very simple yet very easy and safe roto system to clean and worth it. Next, I will tell about the disadvantage of the hydraulic system compared to the pneumatic system. First, disadvantage of the hydraulic system is difficult to handle. If handling hydraulic fluid is messy, and it can be difficult to totally get rid of leaks in a hydraulic system. And if hydraulic fluid leaks in hot areas, it may catch fire. If hydraulic lines burst, they can cause serious injuries to the human. Second is disadvantage of the hydraulic system is easy to damage. Contaminants present in hydraulic fluid damage the performance and productivity of the system. Hence, continuous filtration is required for this system. Third disadvantage of the hydraulic is hydraulic fluids are also corrosive. Faulty hydraulic fluid selection for a system will damage the component. There needs to be proper maintenance when handle the hydraulic system.